Hello to my grade 11 students. So how are you in this pandemic time? Are you still okay? So how did you find answering those numbers of modules? So I hope you find it well and you answer all of those. Anyway, our lesson for this morning is all about polarity of molecules. Have you heard the word polarity or polar? So later, we will discuss all of this. So for our learning outcome, or after going through this module, you are expected to define solubility, miscibility, and polarity. Identify the different types of intermolecular forces of attraction. Explain how polarity of molecules related to its properties. Okay, so which of this is true? Atom and molecule mean the same thing. Second, atoms are made of molecules. And the third one is molecules are made of atoms. Okay, so the correct one is the number 3, which is molecules are made of atoms. Next, what is the smallest structure in this list that can be seen with an ordinary desk microscope? Okay, you have here the cells nucleus, atoms, chain molecules such as proteins. Okay, so the correct one is the cell nucleus. Okay, so let us have some warm-up exercise for our nerve cells before we proceed to the presentation of our lesson. So you will perform a simple activity that will help you recall some basic concepts related to polarity of molecules. Have some fun. So this activity is what we call the word cryptogram. So you have here the direction. Unscramble the letters by placing the correct letter sequence in the shaded boxes to come up with the correct answer for each number. Use the numbered boxes to complete the answer to the riddle below. Okay, so you have here the first word. So what do you think would be the first word? Okay, molecule. Correct. This is molecule. Okay, so for the next one, you try to arrange the letter and form it into correct word. What do you think it is? Okay, that is polar bond. Polar bond. And the next one is lone pair. So that is lone pair. And the last in the slide is, what do you think? Nonpolar bond. Nonpolar bond. Okay? And for this one, how many letters are there? So what do you think it is? Okay, that is electronegativity. Electronegativity. Okay, so for these 4 letters, This is easy, right? So it is an atom. So this is an atom. Now for the riddle, so the hint would be, it shows the three-dimensional arrangement of bonding groups of atoms around its central atom. So what do you think is that? It shows the three-dimensional arrangement of bonding groups of atoms around its central atom. Okay. So it starts with letter M. So it is molecular geometry. So if you're able to answer it, then I think you are ready now for our lesson. So fasten your seatbelt for we are about to take off. So again, analyze the lyrics of the song. Tubig at langis and answer the questions below. So this song is sung by Sharon Cuneta. So if you have a good voice, then you can sing this song. Since I don't have a good voice, then maybe I can just read this for you. Tubig at langis, ang katayuan natin, yan ang kawangis. Pilitin mang magsamay, may mahahapis. Ganyang-ganyan tayong dalawa, ang puntunan ay magkaiba. Langis at tubig di mapasama ng tunay mang pag-ibig. Hinanakit ang siyang laging mananaig. Mahal na mahal man kita, may mahal ka namang iba. Tubig at langis, idarang man sa init, di rin tatamis. Dahil ang halo'y luhat paghihinagpis. Ang kirot ay di maalis kung labis, bakit nanaig ang dusa sa ligaya sa ating daigdig. May dasal ba akong hindi niya naririnig? Papel natin sa pag-ibig, ako'y langis, ika'y tubig. Ako'y langis, ika'y tubig. So, bakit nananaig ang dusa sa ligaya sa ating daigdig? May dasal ba ako? Hindi niya naririnig. Papel natin sa pag-ibig, ako'y langis. Ika'y tubig, ako'y langis, ikaw ay tubig. Okay. So, what do you think is the message of the song? No? What do you think is the message of that song? So, do you think it has relationship or is it related to our topic for today? So, if you're going to add oil to the water, what will happen? Will it create a single homogeneous phase or will it form two layers? And why do you think water and oil can't be mixed even when it is heated? Diba? So if you have noticed, even if we heat the oil and water, still it won't mix or it cannot be mixed. Okay. So in the slide, why is polarity so important? Why do we need to know polarity and the importance of polarity? So try to look at this illustration. Or salt dissolved in water, right? The salt dissolved in water. But how come oil does not? So that is my question. why oil does not dissolve in water and why salt dissolves in water. What will oil dissolve in and why? Okay, let's find out that as we go through with our lesson, our discussion. One of the practical application of polarity of molecule in real-life scenario is manifested on the solubility and miscibility of substances to form solution. So, what is solubility? Solubility is defined as the ability of a solid substance to be dissolved in a given amount of solvent. How about miscibility? Okay, so miscibility is the ability of the two liquids to combine or mix in all proportions, creating a homogeneous mixture. Okay, so the general rule to remember about the solubility and miscibility of molecular compounds can be summarized in a phrase like dissolves like or like mixes with like. So try to connect or relate this to the song Tubig at Langis. So the message of the song simply describes that water and oil can't be mixed or can't be together. Kahit idadaan pa yan sa init, hindi talaga yan mahahalo. Okay? So when you are going to mix something, try to make sure that there is chemistry or chemistry is present even in a relationship. Still, you need chemistry. Pag walang chemistry, then walang kilig sa love life. Diba? So, as the phrase goes, like dissolves like or like mixes with like. So, what do you mean by polarity? Polarity is a state or a condition of an atom or a molecule having positive and also negative charges, especially in case of magnetic or unelectrical poles. Polarity in general refers to the physical properties of compounds such as boiling point, melting points, and their solubilities. So it is a separation of electric charge leading to a molecule or its chemical groups having an electric dipole moment with a negatively charged end and a positively charged end. So which of the following substances below will most likely mix with each other? So try to put a check in the box. So you have here A to E. So water and chloroform, benzene and chloroform, water and vinegar, then acetone and toluene, then carbon tetrachloride and water. So try to think which which of the following substance will most likely mix. Okay, so if you're done, so what do you think or what chemistry concept did you use in answering the question above? If you answer polarity of molecules, then you are right. So great job. So benzene and chloroform are both nonpolar compounds, while water and vinegar are both polar compounds. So thus they are miscible to each other. However, the rest is a combination of polar and nonpolar, and therefore it will not mix, and instead it will form two layers even if it is shaken carefully or stirred properly. Okay, so next we have to discuss about intramolecular forces of attraction. The attractive force that binds atoms together, it exists between molecules. So, the attractive force that binds atoms together. So there are several types of IMFA, and below they are arranged from strongest to weakest. So ion dipole, hydrogen bonding, dipole, dipole, then dipole-induced dipole. Okay, so what do you mean by dipole? A molecule in which a concentration of positive electric charge is separated from a concentration of negative charge. A polar molecule is a molecule containing polar bonds, where the sum of all the bonds' dipole moment is not zero. So polar bonds to form when there is a difference between the electronegativity values of the atoms participating in the bond. So polar molecules also form when the spatial arrangement of chemical bonds leads to a more positive charge on one side of the molecule than the other. So, means the direction of the polar bond in a molecule, or the arrow points toward the more electronegativity. Okay. So how are you going to determine molecular polarity? So it depends on the dipole moments, depends on molecular shape, linear bend, trigonal, planar, and tetrahedral. Now, nonpolar molecules' dipole moments are symmetrical and cancel out. Therefore, polar molecules have a symmetrical shape, the lone pairs, or asymmetrical atoms. So polarity is more of a spectrum than a black and white determination, polar to nonpolar. Now, try to look at this, how molecules bond together. So, weak attractive forces between molecules are what you call the hydrogen bonds. So, if you can see how they are attractive to each other, how the molecules are attractive to each other. You have the hydrogen bonds. Okay. So you have here examples of polar molecules. Water is a polar molecule. The bonds between hydrogen and oxygen are distributed so that hydrogen atoms are both on one side of the oxygen atom rather than evenly spaced. So the oxygen side of the molecule has a slight negative charge, while the side with the hydrogen atoms has a slight positive charge. Then you have the ethanol. Ethanol is also a polar because the oxygen atoms attract electrons because of their higher electronegativity than other atoms in the molecule. Thus, the group of ethanol, oxygen, and hydrogen has a slight negative charge. Also, you have the ammonia, sulfur dioxide, and you have the hydrogen sulfide. So these are all examples of polar molecules. Okay, we have to know more about polar molecules. That polar molecules do not share well at all. Their electronegativity differences are great, are more like ionic compounds. They have higher melting and boiling points, most likely to be liquids at room temperature, like dissolved slide. Use polar ionic solvent to dissolve a polar ionic solute. Okay? So how polarity of molecules related to its properties? Now, molecular polarity is an important factor in how molecules of one type interact with other molecules. For example, polar solvents are better at dissolving polar substances, and nonpolar solvents are better at dissolving nonpolar substances. So can you see the difference? Polarity also influences the way that molecules arrange themselves in the solid and liquid states. Okay, so here, sugar is a polar substance. It's in solution with water, which is also apolar. So when you are going to mix the sugar and water, normally it will mix. So mark where the hydrogen bonds will form. Okay. So more nonpolar molecules. So they share electrons the best, have the closest electronegativities or smallest differences, have lower boiling and melting points. So more likely to be gases at room temperature. So like dissolves like. Use a nonpolar solvent to dissolve a nonpolar solute. Okay? Now, polar to nonpolar electrons transferred is shared unequally, is shared high melting point, boiling point, solid as STP and liquid as. Okay. Now, how are you going to predict polarity and nonpolarity? So this is what you are going to do. So whether a molecule is polar or nonpolar is a matter of its geometry. If one end of the molecule has a positive while the other end has a negative charge, then the molecule is polar. If a charge is evenly distributed around the central atom, the molecule is nonpolar. So, if one end has a negative charge, then the other end has a positive charge, then definitely that is a polar. If it is evenly distributed around the central atom, then definitely that molecule is a nonpolar. So that is how you are going to predict polarity and nonpolarity. Okay, now we will have to discuss the London forces of attraction. The London dispersion force is the weakest intermolecular force. The London dispersion force is a temporary attractive force that results when the electrons in two adjacent atoms occupy positions that make the atoms form temporarily dipoles. So this force is sometimes called an induced dipole attraction. London forces are the attractive forces that cause nonpolar substances to condense to liquid and to freeze into solids when the temperature is lowered sufficiently. Okay, now, because of the constant motion of the electrons, an atom or molecule can develop a temporary instantaneous dipole when its electrons are distributed unsymmetrically about the nucleus. So you have here symmetrical distribution and the asymmetrical distribution illustration. So see, okay, so try to look at the difference between the presentation of this or the illustration of the symmetrical distribution and the asymmetrical distribution. So if you try to look at the nucleus and the electrons, uh, the one is not really symmetrical. And the other one, they are symmetrical. Look at the distribution between. Okay? So the nucleus is inside or in the middle. While the unsymmetrical, try to look at the position of the nucleus and also the position of the electrons. Okay. Now, The second atom or molecule in turn can be distorted by the appearance of the dipole and the first atom or molecule. So because electrons repel one another, which led to the electrostatic attraction between the two atoms or molecules. Okay. So stronger between molecules that are easily polarized, weaker between molecules that are not easily polarized. So that is the explanation of the London dispersion forces. Okay, so try to look at the properties of water. Why water dissolves many molecules, making it an excellent universal solvent? Why water is so good at dissolving things? If you all know that water is a polar molecule and is shaped like a wedge, it is able to break up substances into smaller pieces. So mostly water can really dissolve a lot of things, or it is really a good solvent. So significance to the life of universal solvent. Water is called universal solvent because it is capable of dissolving more substances than any other liquid. This is important to every living thing on earth. It means wherever water goes, either through air, the ground, or through our bodies, it takes along valuable chemicals, minerals, and nutrients. So the structure of water, you have one molecule of water is made up of two hydrogen atoms bonded with one oxygen atoms. So water molecules can form hydrogen bonds. Partially positive hydrogen of one molecule is attracted to the partially negative oxygen atoms of another molecule. So we have here the structure of water. The hydrogen and the oxygen. Okay, two hydrogen atoms and oxygen atoms on the negative side. Okay, so this is the structure of the water, the H2O. H represent hydrogen and 2 represent the number of atoms that is present in the hydrogen, and O represent oxygen and the number of atoms. Okay. So what bonds form water? Polar covalent bond, because since it has a slight positive charge and on one side and a slight negative charge on the other side. So electrons are shared unequally. So meaning to say, water is an example of a polar. So you have here the summary types of intermolecular forces of attraction. So try to familiarize all of this. A type of IMFA, interacting substances, and the examples. For you to be familiar, so please try to put this in mind. Okay. So you have the polar molecules and the non-polar molecules. How do they differ? In their IMFA type, H-bonding and dipole-dipole, and IMFA type and London dispersion. Okay? So they have also their differences. Okay, so let us define the physical properties of substances. You have the boiling point. So temperature at which the vapor pressure and atmospheric pressure of a liquid substance are equal. Melting point, temperature at which solid becomes liquid. At this point, the solid and liquid phases exist in equilibrium. Surface tension, energy needed to increase the surface area by a unit amount. Viscosity, the resistance of the liquid to flow, and vapor pressure, pressure exerted by a substance in its gaseous state. And motility, Volatility measures the rate at which a substance vaporizes. So this changed the form of liquid into gas. Okay. In the simplest sense, boiling point, melting point, viscosity, and surface tension increase as the strength of intermolecular forces increases. On the other hand, vapor pressure and vol volat volatility decrease with increasing strength of IMFA. London dispersion forces increase as the molecular mass of a substance increases. So try to look at the difference. Unlike in edge bonding, as the molar mass increases, the boiling point, melting point, viscosity, and surface tension decreases. So this is their similarities. Okay. So we are done with the polarity of molecules. I hope you I hope you have understood our discussion. Anyway, you can just log into our GAITF site, then proceed to the learning path, then try to look up, try to search for the subject, and you can read more. You have there so many resources that which can help you in understanding more on our discussion. So thank you and God bless.